Welcome everybody to today's webinar. Thank you for the opportunity to talk today. My name is Tina and I represent a company called Ace Plant. Just to give you a little bit of background about ourselves before we get started, we are a plant hire company based in Milton Keynes and we've been in business for over 40 years. Aside of regular plant hire, we specialise in mobile dust suppression applications and bunded fuel storage equipment. Mostly we manufacture our own dust suppression and bunded fuel storage products. We're delighted to be here at the Institute of Quarrying and we hope you will find something useful to take away or think about from today's session. The main purpose of this webinar is to increase awareness in the dangers of dust in the workplace, as well as discuss some of the options and equipment available as a potential solution to certain dust issues. We will also give you an idea of how to adequately determine site requirements using an identify, assess, control and monitor model. This can also, of course, be applied to many situations in the workplace, not just in quarrying or for site dust suppression. This is very much our take on how best to implement dust suppression and dust limitation equipment. There are many variations of products and equipment available within the marketplace and is by no means limited to the equipment mentioned in this session. The main points we will be covering in today's webinar are as follows: dust in the workplace versus health and safety, the main creators of dust in a quarrying environment, liquids to use and not use for dust suppression and a glance at the past, methods of dust suppression as well as looking at efficiency, specific applications for specific sites using the identify, assess, control and monitor model. While dust is often considered to be more of an environmental issue, it is also very much a health and safety risk. Usually, the nature of the dust determines how badly it can affect an individual. For example, larger particles of dust can be an irritant to the eyes, throat and skin, while smaller dust particles, less than 5 microns, can be inhaled, deposited in the lungs and cause respiratory health problems. The highest risk to health is presented by respirable crystalline silica particles, as these are toxic to the defence cells in the lungs and can lead to silicosis. Crystalline silica, or quartz, is found in varying amounts in sand, clays, mud, shale and rocks such as granite. Long-term exposure to high levels of respirable crystalline silica can also lead to an increased risk of developing lung cancer. Other health implications can include, and are by no means limited to, reduced lung function, aggravated asthma and other chronic lung conditions. In rare cases, particles may also increase the risk of heart attacks and strokes in susceptible people. Health and safety executive regulations are clamping down on dust in the workplace. Many substances that can create harmful dust have been given a workplace exposure limit under COSH. Please refer to Guidance Note EH44 on the HSE website via the link shown. There is a downloadable PDF document which is very useful. Not all dusts have been given an exposure limit. However, the lack of limit does not mean that the substance is safe. Where dusts do not have a limit, but there is evidence of potential hazards to health, employers should consider setting their own in-house standards and consider good control practice. Dust is present in almost all quarrying and open cast mining operations. The main creators of dust in a quarry is the movement of vehicles and/or machinery and the excavation and handling of aggregates, whether that's crushing, screening or loading lorries. Fundamentally, this is the bare bones of a quarry, and all of these so-called creators of dust are imperative to the operation of a quarry. Prevention is usually always better than cure, but other than closing a quarry operation entirely to limit the creation of harmful dust, there are very few ways to avoid dust being created in the first place. We will look at some control measures later on in this session. Many years ago, it has been known that diesel was once used on some sites as a method of dust suppression, as it does not evaporate nearly as quickly as water. This, of course, has huge environmental implications which were either not of any concern back then or people were not aware even existed. Fortunately, our awareness of our impact on the environment has grown immensely, and we are still learning more about this today. Nowadays, the most common liquid used for dust suppression is, of course, water. There are some water additives available that are environmentally friendly, which can be added to make water less vulnerable to evaporation, but more common than not, pH 7-ish H2O is what is used. This is mainly due to its availability and mostly low cost, but on sites where water is metered can become quite expensive. This is where efficient methods of dust suppression need to be explored, which we will come on to later in this webinar. Other ways of sourcing water can also be from an on-site lagoon or even rainwater capturing vessels. Sites should be careful with salt water in dust suppression equipment, as this can perish seals in pumps and cause premature rust and wear in machinery. As mentioned at the beginning of this session, there are many different types of dust suppression applications and is by no means limited to the ones about to be mentioned. This is purely our take on different types of water application systems. Once we have discussed some of the options available, we will then look at some on-site dust issues and discover which application could be best for that site. The versions we will discuss range from high volume, site drenching water applications through to far more water efficient mist applications, all with their own unique characteristics. Accompanied with a thorough assessment of site requirements, the correct type of dust suppression application in the correct situation can be very effective. We have found the most common method used for dust suppression across the board is the tractor and vacuum tanker approach. Tankers used in dust suppression can range anywhere between 5,200 litres to over 9,000 litres. The safest type of tanker to use would be ones fitted with a hydraulic vacuum pump as opposed to PTO-powered pumps. Pressure-fed units are normally fitted with a rear splash plate, making it particularly suitable for damping down residual dust on haul roads where a high-volume water application is required. Many crushers and screeners are complete with their own internal dust suppression systems and purely require a bowser to store water. More often than not, they are also fitted with their own pickup pumps. Providing the storage vessel is not under any vacuum or pressure, crushers will happily draw water from external sources, whether that's a tanker as pictured or even a rainwater capturing vessel as mentioned previously. If a pickup pump is not fitted, then a small 1-inch pump mounted on the bowser should provide enough pressure to feed the water jets on the crusher or screener. In situations where water consumption is an issue and efficiency is a must, an option available would be a hydraulically driven carbon fibre spinning disc assembly mounted to the rear of the tanker. Being gravity fed, it uses far less water than pressurised systems and gives the operator greater control. The spinning disc atomises water into a fine mist, dampening residual dust and not soaking an area unnecessarily. 9,000 litre vessels fitted with a rear splash plate can be emptied within 8 minutes under full pressure, whereas the gravity-fed spinning disc system, mounted on the same size capacity unit, can last up to 90 minutes. Obviously, each application has their own specific use. For example, a spinning disc would be a poor choice if a high-volume application is required. When a more targeted and high-volume approach is required, a rain gun provides an alternative solution. Using a high-capacity centrifugal hydraulic pump, a throw of up to 70 metres can be produced. Hydraulically operated from inside the cab of the tractor, rain guns can be accurately directed and are also powerful enough to be used for firefighting. Typical applications for this would be for dampening stockpiles, etc., prior to the agitation of said stockpile by a loading shovel or excavator. Telehandler, forklift, or loader-mounted dust suppression units provides accurate, efficient, and effective dust suppression. It also helps to ensure existing equipment fleets are used to capacity. Using the same carbon fibre spinning disc assembly as the tankers mentioned previously, this system is gravity-fed whilst the spinning disc atomises the water which results in a fine mist that traps dust on the ground and in the air. The spinning disc makes water usage more efficient, economical, and gives the operator greater control. Fan-assisted ranges offer a controllable low water usage solution. Often complete with a remote control, the fan can be aimed, turned on and off, and oscillated at the touch of a button. Larger units are fitted with around a 2,000 litre onboard water tank and a 22 kVA generating set. A throw of around 40 metres can be produced. Moving away from some of the types of equipment available, I'll now begin to explain how this model works that we mentioned at the beginning of the session. We will then look at some examples and apply this model to that specific site. To start off, we obviously need to identify the fact that there is an issue or hazard on site which needs to be addressed. For example, large quantities of airborne dust which is creating respiratory issues in staff and reducing site visibility. Secondly, we need to assess the risk. For example, what are the potential consequences of exposure to the identified hazard? Ultimately, we need to ascertain how bad this identified issue or hazard really is. Thirdly, we then control the risk. If the assessment of the identified risk has found that further action is necessary, control measures should be selected out of the following. Eliminate the risk entirely. This can be achieved through redesigning the activity or equipment, resulting in immediate elimination of said risk, i.e. avoid creating dust in the first place. Reduction of the risk. This can be achieved by enclosing the activity or equipment to capture or absorb the hazard, i.e. dust suppression or dust limitation equipment implementation. Minimising the risk through procedure. This involves implementing systems so that work is carried out in such a way that it limits exposure to the hazard, i.e. avoid working in or near dusty areas or avoid unnecessary movement of machinery, which in turn would create dust. Use of appropriate personal protective equipment. If we cannot avoid a certain activity altogether, i.e. don't create dust in the first place, we cannot reduce the problem, i.e. through dust suppression, and we cannot be away from the problem, i.e. avoid working in near dusty areas, then we will need to directly protect ourselves from the issue. Fourthly, we will monitor the issue to find out whether we have selected the appropriate control measure and the measure is working effectively. It is, of course, possible to select more than one of these control measures. However, please note that by doing so, it may be difficult to separate them and treat them as individuals from a monitoring perspective. For example, if it transpires that the two implemented control measures are not working effectively, it may be difficult to ascertain which of the ones are at fault or requires attention. In terms of dust on site, air monitoring systems can be put in place which assess the air quality in a certain area over a period. In-depth monitoring could also be carried out by occupational health. This concludes the identify, assess, control and monitor model, which we will now attempt to apply to specific sites. Please note, these sites have been picked at random and we are only making our assessments based on what we can see in the pictures. We do not know the full extent of their operation, but these act as a good example. If you study this picture being shown now, at a glance we can identify some sort of dust-related issue. Whilst this is not specifically a quarrying operation, the equipment and type of movements happening act as a good example. Let's apply our model that we know. The dust plume is certainly impacting visibility. This can make the movement of vehicles, machinery and of people very dangerous. There could very well be someone walking or driving a vehicle within the plume of dust in the path of the ADT, which could result in a very serious accident. Secondly, in relation to health, you could argue that operators are safe inside their air-filtered cabs with regards to dust inhalation. However, if you look closely, the loading shovel operator's door is open and in the locked back position. Therefore, the cab is not protecting the operator at all from the elements. What's more, The site offices and welfare cabins in the background are being engulfed by dust. Under assessed, the potential consequences of this dust are: could cause site collision as a result of poor visibility. Someone could very well be seriously injured. We do not know what this dust is, but we should assume serious until proven otherwise. Out of the control measures mentioned previously, can we eliminate the risk entirely? Well, not exactly, as these movements of machinery are necessary for this type of operation. Can we reduce the risk? We could certainly implement some sort of dust suppression, so this is an option. Can we minimise the risk through procedure? We could certainly implement a system that all machinery cab doors and windows will need to be closed. However, is the loading shovel operator's door open for a reason? The air conditioning or fan could not be functioning correct. This would have to be investigated. Use of appropriate PPE. Looking at the loading shovel operator, they are already wearing high-vis clothing. So we now know this is already a site requirement. This would assist us in low visibility as a result of dust. We do not know what the regulations are for this site with regards to masks and eye protection. In conclusion, for the control measures to implement, I believe we have two strong contenders. One, reduce and minimise the risk through some sort of dust suppression application. Two, implement a site rule that all cab doors and windows must remain closed. Cab filters must be frequently inspected and cleaned. Regarding the type of dust suppression application to use in this situation, it appears that most of the dust is being created by the ADT on the haul road. Therefore, a tractor and tanker fitted with a rear splash plate would be a suitable solution, as the whole length of the haul road can be dampened down accordingly, not just a small area. This also suppresses dust at source instead of allowing dust to become airborne and then attempted to dust suppress. If water usage is limited, we could look at using a spinning disc mounted on the rear of the tanker, or even on the front of a loading shovel or telehandler. Once our control measures have been implemented, we could certainly monitor these by not only a visual check, but also using a dust monitor system to assess the air quality. I'm sure that webinars do not usually set homework tasks. However, in this next picture of this crushing plant, see if you can apply the identify, assess, control and monitor model as an exercise. Let's treat the dust as harmful, and the plant is not near any site offices or welfare centres. Hoppers are loaded by one member of staff in a loading shovel with the cab closed. If you revisit this screen at the end of the session, you will be able to pause the screen on this image and apply the model accordingly. This concludes the webinar on dust and dust suppression. We hope that you found this useful and hope that there may be something which you can take away and apply to your own workplace or site. We wanted to use this webinar as an opportunity to give you the tools to assess your own site dust issues and make your own informed decisions about how best to proceed. Thank you very much indeed for listening, and we look forward to receiving any questions you may have.